Today we're going to be talking about Cramer's rule. And I had said in the last video that we would be talking about how we could use determinants to solve a system of equations. And that's exactly what we're going to do. This is what Cramer's rule allows us to do. So if, for instance, if you have a system that looks like this, ax plus by equals c, and dx plus ey equals f, the solution is given by these formulas. This is Cramer's rule. You are going to take the determinant of the matrix C, B, F, E over the determinant of A, B, D, E, and that will be our solution for X. For Y, to find Y, we would take the determinant of the matrix A, C, D, F and divided by the determinant of the matrix A, B, D, E. And this will make a lot more sense when we actually just try a problem. So let's go ahead and do that. Really, it's just a matter of plugging numbers into a formula. So let's take a look. We want to solve this system of equation using Cramer's rule. And I'm going to write this out. I'm going to write out the rule. We have x equals c b f e. That's the determinant of that matrix over the determinant of a b d e. Okay, for y, we take the determinant of a c d f divided by the determinant of a b d e. Okay. Now what we're going to do is we're going to label the parts of our system of equations. 4 is A, -2 is B, C is 10. So it just goes across A, B, C. So the coefficient of the x term on the second one is D. Coefficient of the y term is our E, which is -5, and then 11 is our constant is F. Okay, so now we're just going to plug our numbers right into our formulas. So we are going to have 10 for C, -2 for B, 11 for F, and -5 for E. Underneath, we are going to have 4 for A, 3 for D. We will have -2 for B, and -5 for E. Okay, we're going to do the same thing over here. Let's fill in the correct numbers. We have 4 for A, 10 for C, 3 for D, and 11 for F. And now for the denominator, we have the same thing that we had before, 4, 3, -2, -5. Okay, so now what we're going to do is we're just actually going to find the determinant here. So I'm going to change colors here. So make the x here connecting our numbers. So we've got 10 times -5 minus -2 times 11, all divided by, here's our next one, 4 times -5 minus -2 times 3. So if we do this out, 10 times -5 is -50. So we have -50. Two negatives here make a positive, so basically 2 times 11 gives us 22. And 4 times -5 gives us -20. Negative times a negative is a positive, of course. So we end up with 2 times 3 is 6. So we end up with 28 over 14, which gives us 2. And actually, I think I'm going to move that down to just give me a little more room to do my y. So I'm going to have 28 over 14, which is 2. So x is 2. Okay? And now we're going to do the same thing with y. Find our determinant. So we're going to have 4 times 11. I'm actually going to do this out. 4 times 11 is 44, minus 10 times 3, which is 30. Just save us a little space here. Divided by 4 times negative 5 is negative 20. And it's minus 3 times negative 2, which is negative 6. So, of course, those turn into positive. Positive. So we have 44 minus 30 is 14, divided by negative 20 plus 6, which is negative 14. So y equals negative 1. So we just solved this entire system using Cramer's rule. So let's take a look at another example. We're going to do the same thing. We would like to go to this next problem. I can bring this up. Okay. So again, we need to label our variables like before. There is, I shouldn't say variable. Yeah, well, actually, they are variables. They're coefficients is what they are. We don't have a number listed in front of the y. Put in a 1. So we have A, B, C, D, E, F. Our formula, x is equal to CB, FE, the determinant of, and then the determinant of A, B, D, E. Y is equal to AC, DF, and then we have AB, DE. The denominator is the same. Okay? So what I would like you to do is to finish this problem. I'd like you to plug in the correct numbers in place of the variables, and I'd actually like you to find x and y. And when we come into class, I'd like to talk about that answer before we actually get started with some problems. So thank you for joining me.